Hello students, myself Megha Mane from JSPM Nare Technical Campus Pune. I am associated with Electronics and Telecommunication Engineering Department of the institute. My institute code is EN6755. I welcome you all in our today's session, which we are going to discuss MOSFET and its applications, which is the part of second year engineering of Savitribai Phule Pune University syllabus. Dear student, do you know that in 1949 any computer can took 70 hours to calculate the value of pi in 2000 digits. Now, a smartphone in our hand can calculate the value of pi in 2000 digits by using only 0.5 seconds. This is the miracle of which is increase of speed by using the simple small tiny device inside our electronic gadgets, which is called as a metal oxide semiconductor field effect transistor. Dear student, let us see the history of metal oxide semiconductor field effect transistor. This MOSFET is also called as a MOS transistor. We can see the history of MOS transistor. The MOS transistor is invented in 1959 in a Bell Laboratories. After that, approximately when we calculate the manufacturing of MOS transistor from 1959 to 2020, approximately 15 sextillion, that means 1.5 into 10 raised to 22 transistor, that is MOSFETs, are manufactured from 1960 to till 2020. Now you understand, in every electronic gadget we are using this device MOSFET. Now let us see how this tiny device is constructed. So dear student, let us understand the construction of MOSFET. So first you understand what are the difference between the active devices and passive devices. So dear student, active device is nothing but which can control the flow of current. For example, the active devices are BJT, bipolar junction transistor, field effect transistor, FET, metal oxide semiconductor field effect transistor, MOSFET. So these are the examples of active devices. On the other hand, what is the meaning of passive device? The passive device is nothing but which cannot control the flow of current. The example of passive devices are the capacitor, resistors and transformer, etc. So now you understand that the MOSFET concept, what we are going to study, that MOSFET is an active device. That means MOSFET can control the flow of current. Okay, now let us see what are the different types of MOSFET. The MOSFET is classified into two types. First one is enhancement type MOSFET and second one is the depletion type MOSFET. So enhancement type MOSFET is again classified into two types, N channel enhancement type MOSFET and P channel enhancement type MOSFET. And the second type of MOSFET is depletion type MOSFET. There are depletion type MOSFET is again classified into two types. First one is the N channel depletion type MOSFET and second one is the P channel depletion type MOSFET. Dear student, what is the difference between the enhancement type MOSFET and depletion type MOSFET? If we see the construction of enhancement type MOSFET and depletion type MOSFET, both are same, but the difference is that the channel is absent in initially the channel is absent in enhancement type MOSFET, but where in a depletion type MOSFET channel is present from beginning. So now you understand the enhancement type MOSFET and depletion type MOSFET. Now let us see the construction of N channel enhancement type MOSFET. For construction of enhancement type N channel enhancement type MOSFET, we are using the basic silicon wafer, where in a silicon wafer we are inducing the trivalent impurity, then it makes a P type of semiconductor. Okay, so on that P type of semiconductor we are manufacturing our device, we are preparing our device. So here on a P type of semiconductor we are inducing two N type of well, you can see here. So these two N type of semiconductors are induced into the P type of semiconductors, okay, and the metal contacts are attached to the two N type of semiconductor and the two terminals are brought out. That two terminals are source and drain. Now the main body, which is called as a substrate, which is made up of P type of semiconductor. So through the metal contact we can route out one another terminal which is called as a substrate or body. Now you understand student, we have three terminals, that is source, drain and substrate, correct? Now let us concentrate on gate terminal. So gate is the main controlling terminal in a metal oxide semiconductor field effect transistor. How we can route out the gate terminal? So dear student, we are using the silicon dioxide layer in between the gate terminal and the substrate. You can see here this silicon dioxide layer is very thin layer we are using in between the gate and substrate to differentiate these two terminals, so that this, what is the thickness of silicon dioxide layer? The SiO2 layer approximately thickness is 1000 Armstrong. So very thin layer we are using. Why we are using very thin layer? That is, we want to get must have a control over the surface of that p type of substrate. So dear student, you understand here, in n-channel enhancement type MOSFET we have the drain and source terminal and the substrate terminal and as well as the gate terminal. In an n-channel enhancement type MOSFET, the substrate is made up of p type of semiconductor and the drain and source is made up by using the n type of semiconductor. Vice versa, when we understand the p-channel enhancement type of MOSFET, it is very easy to learn the construction of p-channel enhancement type MOSFET when we know the n-channel enhancement type MOSFET construction, because in a p-channel enhancement type MOSFET, substrate is made up by using the n type of semiconductor and the drain and source terminals are made up by using the p type of semiconductor. Now let us start the operation of n-channel enhancement type MOSFET. But here in operation, what we are going to learn? We are going to learn how the channel is made in n type of in n-channel enhancement mode MOSFET. Okay, so let us start. We know that in enhancement type MOSFET, channel is absent initially. Okay, and the substrate which we are using, which is a p type of semiconductor, and we know that the majority carriers in a p type of semiconductors are hole and the minority carrier in a p type of semiconductors are electron. Okay, where from this p type of semiconductor our substrate. So as we know that p type of semiconductor consists of majority carriers holes and minority carriers are electrons. So now when we apply the small positive supply at the gate terminal, so and the substrate we make a negative, we are connecting negative supply to the substrate. So what the circuit between the gate and substrate, we are compare with the parallel plate capacitor. Okay, so one plate of parallel plate capacitor, first plate is considered as a metallic contact at the gate terminal. So metallic contact at the gate terminal is considered as a one plate. Okay, and another plate of parallel plate capacitor is a substrate, and the dielectric material present between these two plates is nothing but the silicon dioxide layer. Okay, so when we apply the positive supply at the gate terminal, positive charges are accumulated. Okay, and at the substrate terminal negative charges are accumulated. How the negative charges are accumulated at the substrate terminal? Because we know that the substrate is made up of p type of semiconductor and the majority carriers in a p type of semiconductors are the holes. But dear student, the minority carrier in a p type of semiconductors are the electrons. When we apply the positive supply at the gate terminal, the minority carriers, that is electrons, are attracted towards the gate terminal near the surface. Okay, so what happened initially when we apply low gate to source voltage, at that time some electrons are attracted near the surface. When we increase the gate to source voltage, at that time the layer between these two n type of well, it becomes a n type. Initially it becomes less p type, and when we increase the gate to source voltage VGS, it becomes the n type, and then channel is formed in between the two n wells in a n channel enhancement type MOSFET. Okay, understand the polarity conventions of MOSFET. Here always we are making for n channel enhancement type MOSFET, the n gate terminal is connected to the positive and the source terminal is connected to the negative, while the connection between the drain and source, that is the voltage VDS, how we are making, that is drain is connected to the positive terminal and source is connected to the negative terminal. Now what about the substrate terminal? Dear student, we are connecting source and substrate together always. We are short circuiting the source and substrate terminal. The voltage between the source and substrate terminal is 0. So we are considering mainly three terminals, that is gate, drain and source, and we are making gate terminal always positive to turn on the MOSFET. Now let us see different applications of MOSFET. So as we know that the gate terminal is a controlling terminal which controls the MOSFET, hence the MOSFET acts as a switch. Without any mechanical device, MOSFET can be used as a switch. So let us see one example for MOSFET can be used as a switch. Consider the example of heat-based fire alarm. The thermistor decreases its resistance as the temperature increases. Initially at room temperature, resistance of the thermistor is high. So because of this, voltage at the gate terminal is very low. so MOSFET cannot turn on. And once when the temperature of the room is increases, at that time resistance of the thermistor is decreases, and hence the voltage applied at the gate terminal is high and MOSFET get turned on and alarm we can hear. So this is the example for when we use MOSFET as a switch. Now let us see another examples or applications of MOSFET is we can use a MOSFET as a resistor, as a capacitor, we can use MOSFET as a diode. Dear student, we can use MOSFET as an inverter. See, these are the different examples, applications of MOSFET. As well as we can use a MOSFET as a memory element for the static RAM. When 4 MOSFETs are combined together, we can use a MOSFET as a memory element for the static RAM. Another example for the MOSFET is MOSFET we can use as a different digital circuits. So see, these are the different examples for MOSFET we can use as a digital circuits. Another example of MOSFET is the MOSFET we can use as a gate. So these number of gates combined together we can use a processor, and this processor can do a number of arithmetic and mathematical and arithmetic operation. So dear student, we understand that in every electronic gadget MOSFET is there. So these are the different applications of MOSFET. So now we understand that metal oxide semiconductor field effect transistor MOSFET is very important in our electronic industry. So I hope that you understand the basic concept of metal oxide semiconductor field effect transistor through this session. Thank you.